Let's start off with miscellaneous exercise in chapter 5. So last we did exercise 5.3. So now we'll be doing the miscellaneous exercise of complex numbers and quadratic equation. So the solution for the first one, what's the first problem? We'll see. Evaluate I to the power of 18 plus 1 by I to the power of 25 whole cubed is given. So what's the solution of this? We'll see. So in the solution part here you have that given that I to the power of 18 can be written as I to the power of 16 into I square, which is equal to, can be written as I to the power of 4 whole to the power of 4 into I square. So now you know that this is equal to, it can be written as I square into I square whole to the power of 4 into I square. You know that since I square is equal to minus 1, you can write this as minus 1 into minus 1 whole to the power of 4 into I square. So since it's to the even power, you will get this as plus 1 into minus 1, which is equal to minus 1 we have got here. So therefore now this is minus 1, the first part. Now what's the second part? We'll see. It is 1 by I to the power of 25, which is equal to 1 by I to the power of 25, which is equal to 1 by I to the power of 24 into I, which is equal to 1 by I to the power of 4 whole to the power of 6 into I, which is equal to 1 by I square into I square whole to the power of 6 into I. Now we know that since I square is equal to minus 1, you can write this as equal to 1 by minus 1 into minus 1 whole to the power of 6 into I, which is equal to 1 by minus 1 to the power of 6. Since it's even power, you'll get it as 1 into I. So you're getting this here, the value as 1 by I. This is 1 by I shouldn't be in the denominator, so we multiply and divide by I. This is equal to I by I square, which is equal to I by minus 1, which is equal to minus I. So now we got this as I minus I. So therefore I to the power of 18 plus 1 by I to the power of 25 whole to the power of 3 can be written as equal to minus 1 minus I whole cubed, which is equal to, you can write this as minus 1 plus I this whole cube. Since it is to the power of 3, you will get a minus sign outside. So therefore you can use the formula for this, a plus b whole cubed. So 1 cubed, and this is I cubed over here. So therefore now this is equal to minus 1 plus 3i plus, here 3 into minus 1 you're getting, plus this can be written as I square into I, means it becomes minus I over here. So therefore this is equal to minus of 1 plus 3i minus 3 minus I. So you're getting here it is equal to minus of 3i, 1 minus 3 is minus 2 plus 2i. So when you're taking minus inside, you're getting 2 minus 2i is the answer. So what is given in the second problem? Here it's given for any two complex numbers z1 and z2, prove that real of z1 z2 is equal to real of z1 into real of z2 minus imaginary of z1 into imaginary of z2. So now here in the solution part, how do we proceed here? We'll see. So here let z1 be equal to x1 plus I y1 and z2 be equal to x2 plus I y2. So then what is real of z1? Real of z1 is equal to x1, imaginary of z1 is equal to y1, real of z2 is equal to x2, and imaginary of z2 is equal to y2. So we wrote all this. So now we can write here what is given in this is asking real z1 into z2. So z1 into z2 is equal to x1 plus I y1 into x2 plus I y2, which is equal to x1 x2 plus I x1 y2 plus I y1 x2 plus I square y1 y2. So this is equal to x1 x2 plus, here you will be getting it as, and here I square into y1 y2 plus I into x1 y2 plus y1 x2 you are getting. So this is equal to x1 x2 minus y1 y2 plus I into x1 y2 plus y1 x2. So here you are having, therefore real of z1 z2 is equal to x1 x2 minus y1 y2, which implies that it is equal to real of z1 into real of z2 minus imaginary of z1 into imaginary of z2. This is the answer. Now minus 2 by 1 plus I into 3 minus 4i by 5 plus I to the standard form. Standard form is x plus iy. We have to bring it into that form. So now here in the solution part, how do we do this? We'll see. So this is equal to, you are having in the question 1 by 1 minus 4i minus 2 by 1 plus I into 3 minus 4i by 5 plus I is given. So first we'll take the LCM of this. So this is equal to, here you have 1 minus 4i into 1 plus I. So you're getting a 1 plus I minus 2 into 1 minus 4i, and this is into 3 minus 4i by 5 plus I. So this is equal to 1 plus I minus 2 plus 8i divided by, you will get here 1 plus I minus 4i minus 4i square into 3 minus 4i by 5 plus I. So this is equal to 1 minus 2 is minus 1 plus 9i into 3 minus 4i divided by, in the denominator here you know that this will be written as 4 into minus 1. So because minus 4 into minus, it will become plus 4. So it becomes 5 minus 3i into 5 plus I. So now again when we again multiply, here you are going to get it as minus 3 plus 4i plus 27i plus 36i square, it is minus here. So minus 36i square divided by 5 5s are 25 plus 5i minus 15i minus 3i square. So this is equal to, now this is I square is equal to minus 1. So minus 36 into minus 1 will give you plus 36. Plus 36 minus 3 is 33 plus, here you are getting it as 31i divided by, here you are going to get minus 3 into, here you are getting this as minus 1, I square is minus, so minus 3 into minus 1 will give you plus 3. So 28 minus 10i. So now this you are getting here. So now you can rationalize this by taking 28 plus 10i divided by 28 plus 10i, which is equal to, you are going to get it as 924 plus 868i plus 330i plus 310i square divided by 28 whole square minus 10i whole square. So which is equal to, you are going to get this as 924 plus 1198i minus 310 divided by 28 square is 784. I'm sorry, 784 minus 100i square. So which is equal to 924 minus 310 is 614 plus 1198i divided by 784 plus 100, which is equal to 614. If you take out 2 common in the numerator, what will we get? We'll see. So if you take out 2 common in the numerator, you're going to get it as 307 plus 599i divided by 884. So 2 ones are 442s are here, you're going to get. So 307 by 442 plus 599i by 442. This is the answer. See, squaring on both sides, we get x minus iy whole square is equal to a minus ib by c minus id. The square root will be going. So now this, taking modulus on both sides, how can we write this? X minus iy whole square is equal to mod of a minus ib by c minus id. Now we know that this is equal to x minus iy whole square mod is equal to mod of a minus ib by mod of c minus id. Since we know that mod of z square is equal to mod z whole square, or and also you know that mod of z1 by z2 is equal to mod of z1 by mod of z2. Iy whole square this is. And we know that mod means, we have seen in the previous exercises doing this. So this is equal to root of x square plus y square whole square, which is equal to root of a square plus b square divided by root of c square plus d square. Since x minus iy mod is equal to root of x square plus y square. So now we have this equal to, implies x square plus y square is equal to whole square is also. Okay, the whole square is going to get cut off c square plus d square. Now again squaring on both sides, we get x square plus y square whole square is equal to a square plus b square by c square plus d square. So now this is the solution of the given problem. We had to prove this only. X square plus y square whole square is equal to a square plus b square by c square plus d square. Next, going into the next problem, that is the fifth one. What's the fifth one? We'll see. Fifth one here, in this you have 1 plus 7i divided by 2 minus I whole square is equal to 1 plus 7i divided by 4 plus I square minus of 4i, which is equal to 1 plus 7i divided by 4 minus 1 is 3 minus 4i, since I square is equal to minus 1. Now this is equal to, here you can write this as equal to 1 plus 7i, rationalize the denominator, 3 minus 4i into 3 plus 4i divided by 3 plus 4i. So rationalizing the denominator, will get here equal to 3 plus 4i plus 21i plus 28i square divided by a plus b into a minus b is 3 square 9 minus 16i square. So which is equal to, you are going to get this as 3 plus 3 minus 28 you will be getting, because 28i square is this, minus 28 plus 25i divided by 9 plus 16, which is equal to 25, since I square is equal to minus 1. So therefore now this can be written as minus 25 plus 25i divided by 25, which is equal to minus 25 by 25 plus 25i by 25, which is equal to minus 1 plus I. So this is the answer for this. Now going into the second one. What's the second one? We'll see. Second one, we have 1 plus 3i by 1 minus 2i. So 1 plus 3i by 1 minus 2i is equal to 1 plus 3i by 1 minus 2i. We are rationalizing the denominator, so we are taking the rationalizing factor as 1 plus 2i. So which is equal to 1 plus 2i plus 3i plus 6i square divided by 1 minus 4i square. So next this is equal to here 1 minus of 6 is minus 5 plus 5i divided by 5 we are getting, which is equal to minus 5 by 5 plus 5i by 5, which is equal to minus 1 plus I is the answer. So we are getting this is the answer for these, or convert into polar form we have done. Okay, now we have to convert this into polar form. Do this, we'll see. So here you are having, let r cos theta be equal to minus 1 and r sin theta be equal to 1. So on squaring and adding both of them, we obtain r square cos square theta plus r square sin square theta is equal to 1 plus of now to write this equation in polar form, we have it as equal to minus 1 plus I. So let r cos theta be equal to minus 1, r sin theta is equal to 1. On squaring and adding, what do we get? We'll see. On squaring and adding, we get r square cos square theta plus r square sin square theta is equal to minus 1 whole square plus 1 whole square. So here you can take out r square common, so you're going to get it as cos square theta plus sin square theta is equal to 1 plus 1, that is 2. So therefore this implies that r square is equal to 2, which implies r is equal to root 2. Here we know that cos square sin square theta plus cos square theta is equal to 1, and here r is greater than 0 we have got, since r is equal to root 2. Therefore root 2 cos theta is equal to minus 1, substituting the value of theta in these two. So you get it as r cos theta is equal to minus 1, r sin theta is equal to, so this is root 2 sin theta is equal to 1, or cos theta is equal to minus 1 by root 2 and sin theta is equal to 1 by root 2. So now here, therefore theta here lies in the second quadrant, because you know that all silver teacups. This is the first, second, third and fourth quadrant. This lies in the second quadrant. Theta lies in the second quadrant as sine is here. What is the argument which we are having over here? It is equal to nothing but, therefore theta is equal to pi minus of pi by 4 we have seen in the previous exercise, which is equal to 3 pi by 4. Therefore z is equal to r cos theta plus I r sin theta is equal to, here you will get r is nothing but root 2 cos of 3 pi by 4 plus I sin of 3 pi by 4, or this can be written as equal to root 2 common if you take cos 3 pi by 4 plus I sin 3 pi by 4 is the answer. So now this is the required polar form. Is the required polar form. So now here second one, here we have, what is the second one? We have z is equal to 1 plus 3i by 1 minus 2i. So here we have z is equal to 1 plus 3i by 1 minus 2i. So here if we rationalize the denominator, here you will get it as 1 plus 2i divided by 1 plus 2i, so which is equal to 1 plus 3i, 1 plus 2i plus 3i plus 2i or 6i square divided by 1 minus of 2i whole square, that is 4i square. So which is equal to 5. Now I square is equal to minus 1. So therefore this becomes minus 6 plus 1 is minus 5 plus 5i divided by 5, because 1 plus 4 it becomes. So which is equal to minus 1 plus I. So here again let r be equal to cos theta, which is equal cos theta, r cos minus 1, r sin theta is equal to 1. So on squaring and adding, what do we get? We'll see. On squaring and adding, we get r square cos square theta plus r square sin square theta is equal to minus 1 whole square plus 1 square. So here you can write this as r square into cos square theta plus sin square theta. If you are taking r square common, it's equal to 2. So therefore you are getting r square is equal to 2, which implies r is equal to root 2. Since here you are having cos square theta plus sin square theta is equal to 1 and r is greater than 0. So therefore here you are getting r is equal to 2. So therefore root 2 cos theta is equal to minus 1. Root 2 sin theta is equal to 1. So cos theta is equal to minus 1 by root 2. Sin theta is equal to 1 by root 2. So now here again theta lies in the, since sin is positive, theta lies in the second quadrant as we seen in the above. So this here you will get, therefore theta is equal to pi minus of pi by 4, which is equal to 3 pi by 4. So therefore z is equal to, in polar form how do we write, r cos theta plus r sin theta. So which is equal to root 3 cos 3 pi by 4 plus I root 2 sin 3 pi by 4. This is root 2. So if you are taking out root 2 common, you will get here cos 3 pi by 4 plus I sin 3 pi by 4. This is the answer. This is the required polar form, or is the required polar form. X plus 20 by 3 is equal to 0. Here we have to solve by using the discriminant. And what do we get? If discriminant under discriminant we are getting a minus sign, we'll get a complex number. So how do we do that? We'll see. So here solution for this, we have done this one whole exercise of this type. So the given quadratic equation is, the given quadratic equation is 3x square minus 4x plus 20 by 3 is equal to 0. So now we are taking the LCM, you will get it as 9x square minus 12x plus 20 is equal to 0. So now comparing it with, now comparing this equation with the general form, that is ax square plus bx plus c equal to 0. We have here a is equal to 9, b is equal to minus 12, c is equal to 20. Therefore the discriminant is equal to, therefore capital D, which is called as the discriminant, is equal to b square minus 4ac, which is equal to, b square is equal to minus 12 minus of minus 12 whole square it is. So here this whole square minus of 4 into 9 into 20, which is equal to, you're getting this as 144 minus of, this is 80, so 720 you're getting, which is equal to minus 576. So therefore the required equation is, the required solution is, solutions are, what are the required solutions? We'll see, which is equal to, you have minus b plus or minus root of b square minus 4ac by 2a. You can write this as minus b plus or minus root of discriminant divided by 2a, which is equal to minus of minus 12 plus or minus root of minus 576 divided by 2 into 9. So which is equal to 12 plus or minus root of 576 into my root of minus 1. So therefore which is by 18. So which is equal to, here you will be getting it as 12 plus 24 I divided by 18, since root of minus 1 is equal to I. So this is equal to, if you are taking a common factor, here you can divide the numerator and denominator by 6. So if you take out, 6 if you are taking out common, here you are getting 2 plus or minus 6 4s are 24 divided by 6 into 3. So 6 will get cancelled over here. So this is equal to 2 plus or minus 2 by 3 plus or minus 4 by 3 I. This is the answer. So next we'll go into the next one. Given equation is, solution, given equation is x square minus 2x plus 3 by 2 is equal to 0. Comparing it with the, now if you take LCM here, you will be getting it as 2x square minus 4x plus 3 is equal to 0. Comparing with the general form, so a is equal to 2, b is equal to minus 4, c is equal to 3. So now here we will find out what is the discriminant. D is equal to b square minus 4ac, which is equal to minus 4 whole square minus 4 into 2 into 3. So which is equal to 16 minus 4 2s are 8, 8 3s are 24. So which is equal to minus 8 we are getting. So therefore D is equal to minus 8. So the roots, the solution for this problem here, how do we solve this problem, we'll see. So here therefore the required solutions are, therefore the required solutions are d is equal to minus b plus or minus. From now on we'll be writing root of b square minus 4ac by root d, which is the discriminant, by 2a, which is equal to minus of minus 4 plus or minus root of minus 8 divided by 2 into 2, which is equal to minus 4 plus or minus root of, this can be written as root 8 into root of minus 1 divided by 4. So which can be written as minus 4 plus or minus 2 root 2 I divided by 4. So you can take out 2 common in the numerator and denominator. So you will get it as 2 plus or minus root 2I by 2. This is the answer which we are getting. Or you can also write this as equal to 1 plus or minus root 2 by 2 I. This is also one of the answer. Here you are having root of minus 1 is equal to I. Now going into the next 8th one, solution for this. So the given quadratic equation is, the given quadratic equation is 27x square minus 10x plus 1 is equal to 0. So on comparing with the general form, ax square plus bx plus c equal to 0, a is equal to 27, b is equal to minus 10, c is equal to 1. So now we'll find out what is the discriminant. D is equal to root of b square minus 4ac, which is equal to under root of minus 10 whole square minus of 4 into 27 into 1. So which is equal to, here you will get it as under root of 108, which is equal to minus 8. So therefore the required solutions are, the required solutions are minus b plus or minus root of 13, root of d divided by 2a, which is equal to minus of minus 10 plus or minus root of minus 8 divided by 2 into 27. So which is equal to 10 plus or minus 2 root 2I divided by 54. Here root minus 1 is equal to I. Because root 8 can be written as, you can write this as 10 plus or minus root 8 into root minus 1 divided by 2 into 27, that is 54. So here you are getting it as, you can take out here 2 common in the numerator and denominator. So you will get it as 5 plus or minus root of 2 root 2 7. Or if you write it separately, you will be getting it as equal to 5 by 27 plus or minus root 2 by 27I. What's the 9th problem? We'll see. Here you are having 21x square minus 28x plus 10 is equal to 0. Comparing it with the general form, ax square plus bx plus c is equal to 0. You get a is equal to 21, b is equal to minus 28, c is equal to 10. Then find out what is the discriminant. Discriminant is equal to capital D, which is equal to b square minus 4ac. So minus 28 whole square minus 4 into a is 21 into c is 10. So here you are going to get it as equal to 28 square is how much? Here you are going to get it as equal to 784 minus of 840 is equal to minus 56. So therefore the required solutions are you're going to get it as minus b plus or minus root d by 2a, which is equal to minus of minus 28 plus or minus root of minus 56 divided by 2 into 21. So which is equal to 28 plus or minus root of 56i divided by 42. So which is equal to 28 by 42 plus or minus 2 root 14 divided by 42i, which is equal to 2 by 3 plus or minus root 14 by 21i. This is the answer. Now going in the 10th. So what's the 10th one? We'll see. It's given that if z1 is equal to 2 minus I, z2 is equal to 1 plus I, find z1 plus z2 plus 1 divided by z1 minus z2 plus 1 and a mod. So solution over here you are having z1 is equal to 2 minus I, z2 is equal to 1 plus I. Therefore mod of z1 plus z2 plus 1 divided by z1 minus z2 plus 1, which is equal to, here you are going to get it as equal to 2 minus I plus 1 plus I plus I divided by 2 minus I plus minus 1 plus I plus 1. So this is equal to 4 by 2 minus 2I okay, this is the denominator 2 minus 2I, which is equal to 4 by 2 into 1 minus I. So now again you rationalize this, you get 4 by 2 into 1 minus I into 1 minus I divided by 1 minus I under mod. So therefore here what are we getting is equal to, because 2 ones are 2 twos are 2 into 1 minus I divided by 1 plus I. We have to rationalize it with 1 plus I. So 1 plus I divided by 1 plus I divided by 2, which implies that mod of 1 plus I is equal to root of 1 square plus 1 square, which is equal to root 2. So the value of mod of z1 plus z2 plus 1 divided by z1 minus z2 plus 1 is equal to root 2 is the answer. Problem. What's the 11th problem? Let's see. It's given that if a plus ib is equal to x plus I whole square by 2x square plus 1, prove that a square plus b square is equal to x square plus 1 whole square by 2x square plus 1 whole square. So here in the solution part, what do we have? We'll just see. So it is given that a plus ib is equal to x plus I whole square divided by 2x square plus 1. So which is equal to x square plus I square plus 2xi divided by 2x square plus 1. So which is equal to x square minus 1 plus 2ix divided by 2x square plus 1. So which can be written as x square minus 1 by 2x square plus 1 plus I into 2x by 2x square plus 1. So now on comparing the real and imaginary parts, we obtain a is equal to x square minus 1 by 2x square plus 1. And what is b? That is the imaginary part, which is equal to 2x by 2x square plus 1. So therefore here what we have to prove, a square plus b square. So what is a square plus b square? We'll see. It's equal to x square minus 1 by 2x square plus 1 whole square plus 2x by 2x square plus 1 whole square. So this can be written as x to the power of 4 minus 2x square plus 1 plus 4x square by 2x square plus 1 whole square. So this is equal to, here you will be getting it as x to the power of 4 plus 2x square plus 1 divided by 2x square plus 1 whole square. So this can be written as a square plus b square is equal to x square plus 1 whole square divided by 2x square plus 1 whole square. So therefore a square plus b square is equal to x square plus 1 whole square divided by 2x square plus 1 whole square. So this is the solution which we got. This is the answer which we are having. Now go to 2 minus I, z to be equal to minus 2 plus I. Find real part of z1 z2 by z1 and imaginary part of 1 by z1 bar into z1 bar. So imaginary part of that we have to find out. So what is the solution? We'll see. Now here it is given that z1 is equal to 2 minus I and z2 is equal to minus 2 plus I. So here in the first part what do we have? What is z1 into z2? We'll see. So it is 2 minus I into minus 2 plus I. So this is equal to, what are we getting here? Minus 4 plus 2I plus 2I minus I square. So which is equal to minus 4 plus 4I minus I square. This is I square, isn't it? Minus of minus 1, since I square is equal to minus 1. So this is equal to minus 4 plus 1 plus 4I, which is equal to minus 3 plus 4I. We got this. Now z1 is equal to 2 plus I. Z bar, because you are having here, you have to find in the next one what is z1 bar also. So here z1 is equal to 2 plus I means the rationalizing factor, that is bar means it become plus in between. So therefore z1 into z2 by z1 bar is equal to, so in this we have it is equal to minus 3 plus 4I divided by 2 plus I. So now here rationalizing the denominator, what do we get? Rationalizing the denominator or multiplying the numerator and denominator by 2 minus I by 2 minus I. So therefore we get here, therefore z1 into z2 divided by z1 bar is equal to minus 3 plus 4I divided by 2 plus I into 2 minus I by 2 minus I. So which is equal to, here you are going to get it as minus 6 plus 3I plus 8I minus 4I square divided by 2 square minus of I square. So you are going to get this as equal to minus 6 minus, and here I square, so you get minus 6 plus 11I minus of 4 into minus 1, because I square is equal to minus 1 divided by 2 square into minus of minus 1. So which is equal to minus 6 plus 4, which is equal to minus 2 plus 11I. This is 11I, 11I divided by 2 square plus 1. So here you are getting it as minus 2 plus 11I divided by 5. So which is equal to minus 2 by 5 plus 11 by 5I. So now we are comparing the real parts and the imaginary parts. We don't need the imaginary part, but we're just writing it down here. So real part is what? Real of z1 z2 divided by z1 bar is equal to minus 2 by 5 is the answer. And if you want what is the imaginary part of z1 z2 divided by z1 bar, it is equal to nothing but 11 by 5. This is the answer. Now here next second bit what we have here, we have that 1 by z1 into z1 bar we have to do. So 1 by 2 minus I into 2 plus I is equal to 1 equal to, you are getting it as 1 by 2 square plus 1 which is equal to 1 by 5. So here you are having what is here on comparing the real part and the imaginary part, real part and the imaginary part of 1 by z1 into z1 bar, you will get it as real of 1 by z1 into z1 bar is equal to 1 by 5 and imaginary of 1 by z1 into z1 bar is equal to nothing but 0. So here this is the value which we have to find out, the imaginary part, so therefore it is equal to 0. In the first one we had to find out what is the real part. So we had to find out what is this, but we even wrote down what is the imaginary part. Following complex number, given complex number is 1 plus 2i by 1 minus 3i. So in the solution part, how do we do this? We'll just see. So here you are given that let z be equal to 1 plus 2i by 1 minus 3i. Then you have to rationalize the denominator. So therefore z is equal to 1 plus 2i by, because you're having, if you're having either a radical or a imaginary number in the denominator, we always have to rationalize. We know this, isn't it? So therefore we have to always rationalize the denominator. So here when it is 1 minus 3i, it will become 1 plus 3i by 1 plus 3i. It's not changing the value of this. So therefore we are multiplying and dividing it by this. So z is equal to 1 plus 3i. If you are multiplying it, you will get it as 1 plus 3i plus 2i plus 6i square divided by 1 square minus of 3i whole square. So which is equal to 1 minus of 6 plus 5i divided by 1 minus of 9i square. I square is equal to minus 1. So therefore you are getting it as minus 5 plus of 5i divided by 1 plus 9 which is equal to 10. So therefore minus 5 by 10 plus 5 by 10 I which is equal to minus 1 by 10 plus minus 1 by 10 I. So by 2 I. That is the value which we got after rationalizing. Now here what we have to find out, what is the modulus and also the argument. So in order to find out that, what will we do? We'll just see. So now here we have z is equal to, here we can take, let z be equal to r cos theta plus I r sin theta. So that is, we got r cos theta is equal to, from this you know that z is equal to minus 1 by 2 plus equal to minus 1 by 2 and r sin theta is equal to 1 by 2. So now on squaring and adding, we obtain r square cos square theta is equal to 1 by 4 and here r square sin square theta is equal to 1 by 4. So therefore here you can write this as r square into cos square theta plus sin square theta is equal to minus 1 by 2 whole square plus 1 by 2 whole square, which is equal to, which implies r square into 1 is equal to 1 by 4 plus 1 by 4, which is equal to half. Therefore, which implies that r is equal to 1 by root 2. So, therefore, r cos theta plus r I r sin theta is equal to 1 by root 2 cos theta is equal to minus 1 by 2, and here you are having 1 by root 2 sin theta is equal to 1 by 2. So therefore you are going to get this as equal to this value. That is only r value we substituted so that we can get what is it. So now here you, in order to find out the argument and the modulus also, we need this. So therefore here you can write this as cos theta is equal to minus 1 by 2 by 1 by root 2 means it becomes 1 by root 2, and sin theta is equal to 1 by root 2. So now here you know that in which quadrant is the cos negative all silver tea cups. So cos is negative in the second and the third quadrant. So now here in this you have sin theta is positive in this, so it lies in the second quadrant. Therefore you can write here theta lies in the second quadrant. So therefore you are getting it as theta. Therefore theta is equal to pi minus of pi by 4, which is equal to 3 pi by 4. Therefore the modulus and argument of the given complex numbers are 1 by root 2 and 3 pi by 4 respectively. So now we'll go into the next problem. There's a So here you're having this 14th problem. Find the real numbers x and y if x minus iy into 3 plus 5i is the conjugate of minus 6 minus 24i. So in the solution part here, how will we proceed? We'll see. You know that let z be equal to x minus iy into 3 plus 5i. So z is equal to 3x plus 5xi minus 3iy minus 5i I square. So which is equal to 3x plus 5xi, and this one you can write as it is, plus 5xi minus 3iy plus, because here y I square is equal to minus 1, minus into minus will give you plus, so you will get here 5i. So this is equal to 3x plus 5i plus I into 5x minus 3y. So therefore z bar is equal to 3x plus 5y minus of I into 5x minus of 3y. So only the sign in between will change, but not in the brackets, it will not change for bar. So therefore here equating the real and imaginary part, it is given that what is given? Given that z is equal to minus 6 minus 24i. So therefore we have 3x plus 5y is equal to minus 6, or you will write down the whole thing, and then x minus 3y is equal to minus 6 minus 24i. So equating real and imaginary parts, we obtain 3x plus 5y is equal to minus 6. 5x minus 3y is equal to 24. So equation 1 and equation 2. So here you can multiply this first equation with 3 and the second one with 5. So what will we get here? We'll see if this is equation 1 and this is equation 2. So multiplying equation 1 with 5, 3 into equation 1 and 5 into equation 2. So this we are doing. So here you will be getting it as 3x plus 15y is equal to minus 18. Here you are getting 25x minus 15y is equal to 24 into 5 is 120 you are getting. So therefore this will get cancelled. Here you are getting it as, this is 3x plus 5y. So here you will have 9x. So 9 plus this one, it will be giving as 34x is equal to 102. So therefore x is equal to 102 by 34, which is equal to 3. So putting the values of x in equation 1, put the value of x in equation 1. What do we get? What is the equation? 3x plus 5y is equal to 6. 3x plus 5y is equal to 6. So it's just 3 into 3 plus 5 into y is equal to 6. So you're getting here 5y is equal to 6 minus 9, which is equal to minus 3. Y is equal to this is minus 6. This is also minus 6. Minus 15. So here you are going to get it as minus 15 by 5, which is equal to minus 3. Thus, the values of x and y are 3 and minus 3 respectively. So now we'll go into what is the modulus of 1 plus I by 1 minus I minus 1 minus I by 1 plus I. So in the solution part, what do we have here? We have it is equal to 1 plus I by 1 minus I is minus of 1 minus I by 1 plus I, which is equal to 1 plus I whole square minus 1 minus I whole square divided by 1 minus I into 1 plus I. So which is equal to 1 plus I square plus 2I minus 1 minus I square plus 2I divided by 1 square minus I square is nothing but plus 1 square itself. So therefore this is equal to, you are going to get it as 1. Here this is I square is equal to minus 1, means here you can write this as plus 1. So 1 plus 1, 2 minus 1 is 1 we are getting. And 1 minus of this, so you are going to get it cancelled. This is getting cancelled, this is getting cancelled, this. So you are getting 4I by 2I. So II is getting cancelled here. It is, I'm sorry, it is 2 only down in the denominator. So 4I by 2, which is equal to 4I by 2, which is equal to 2I. Therefore, mod of 1 plus I by 1 minus I minus 1 minus I by 1 plus is equal to mod of 2I, which is equal to root of 2 square, which is equal to 2 is the answer. So now going into the 16th problem. What's the 16th problem? We'll see. If x plus iy whole cubed is equal to u plus iv, then show that u by x plus v by y is equal to 4 into x square minus y square. So in the solution part, what will we have here? It is equal to x plus iy whole cubed is equal to u plus iv. So which is equal to, you are going to get this as x cube plus iy whole cube plus 3 into x into iy into x plus iy, which is equal to, you can take this as equal to u plus iv. It's given on there. So this is equal to, here you're going to get it as x cube plus I cube y cube plus 3x square yi plus 3xy square I square, which is equal to u plus iv. So which implies here you're going to get it as x cubed plus 3x square yi minus 3x y square, because I square is equal to minus 1 we have substituted over here. So which is equal to u plus iv. Or you can write this as x cube plus I into 3x square y minus of y cubed, which is equal to u plus iv. So on equating real and imaginary parts, we get u is equal to x cube minus 3x y square, v is equal to 3x square y minus y cubed. So therefore u by x plus v by y is equal to x cube minus 3xy square divided by x plus 3x square y minus y cube divided by y. So therefore you are going to get this as equal to x into x square minus 3y square plus y into 3x square minus y square divided by, here by x and here by y. So now this is equal to, here you can take this as, if x is getting cancelled over here, you are going to get it as x square minus 3y square plus 3x square minus of y square, which is equal to 4x square minus 4y square, which is equal to 4 into x square minus y square. Therefore u by x plus v by y is equal to 4 into x square minus y square. Hence the proof. So now, so what's the 17th one? We are having it as equal to, if alpha and beta are the different complex numbers with mod of beta equal to 1, then find beta minus alpha by 1 minus alpha bar into beta. So how do we do the solution? We'll just see. Here what's given to us, we have let alpha be equal to a plus ib and beta be equal to x plus iy. So we are taking these two. So it is given what is given to us, mod of beta is equal to 1, right? So therefore here you are having, therefore root of x square plus y square is equal to 1, which implies that x square plus y square is equal to 1. This is equation 1. So then you are having here mod of beta minus alpha divided by 1 minus alpha bar into beta, which is equal to x plus iy minus a plus ib divided by 1 minus a minus ib into x plus iy. So which is equal to, you are going to get it as x minus a plus of I into y minus b divided by 1 minus of ax plus aiy minus ibx plus by. So therefore this is equal to x minus a plus I into y minus b divided by 1 minus ax minus by plus I into bx minus of ay. if you are taking the minus sign inside, you are going to get this inside the bracket. It is equal to x minus a plus, you have to take here mod means root of a square plus b square we have to do. So only what is the real part, and a whole square plus y minus b whole square divided by under root of 1 minus ax minus by whole square plus bx minus ay whole square. So this is equal to under root of x square plus a square minus 2ax plus y square plus b square minus 2by divided by root of 1 plus a square x square plus b square y square minus 2ax plus 2ab xy minus 2by plus b square x square plus a square y square minus 2abx y. So now this is equal to under root of x square plus y square plus a square plus b square minus 2ax minus 2by divided by under root of 1 plus a square into, taking a square common, x square plus y square plus b square into y square plus x square minus 2ax minus 2by. So which is equal to under root of, you are going to get here equal to 1 plus, since we know that using equation here using 1, we have named one equation over here as 1, isn't it? Using 1 we having x square plus y square is equal to 1 plus a square plus b square minus 2ax minus 2by divided by 1 plus, here also wherever x square plus y square is there, we are putting it as 1. So you are getting 1 plus a square plus b square minus 2ax minus 2by. If you are cancelling this out, it's equal to 1. So therefore mod of beta minus alpha divided by 1 minus alpha bar into beta is equal to 1. So now going into the next one, that is the solutions of the equations is given over here. So what is the solution of this, we'll see. So here you are having, it is 1 minus I mod whole to the power of x is equal to 2 to the power of x. So whenever we are having a mod, we'll take root of real number plus square plus imaginary number square. So you are getting 1 square plus of minus 1 whole square, which is equal to, and this is whole to the power of x is equal to 2 to the power of x. So you are getting this as equal to root of 2 whole to the power of x is equal to 2 to the power of x, that is 2 to the power of x by 2 is equal to 2 to the power of x. So therefore now since the base is equal, you can equate the power. So x by 2 is equal to 2, x by 2 is equal to x you are getting. So which implies that x is equal to 2x, or 2x minus x is equal to 0, which implies that x is equal to 0. Thus 0 is the only integral solution, of the given equation. Therefore the number of non-zero integral solutions of the given equation is 0. Next, going into the 19th one, into g plus ih is equal to a plus ib, then show that a square plus b square plus c square plus d square into e square plus f square into g square plus h square is equal to a square plus b square. So in the solution part over here, Now what is given this? We can write this as a plus ib into c plus id into e plus if into g plus ih into is equal to a plus ib. So therefore if you are taking mod of this both the sides, so if you are taking mod in this way for both the sides, what do we get here? We get this is equal to, now mod again you can write down each one again in a different mod. So you can write this as c plus id into e plus if mod into g plus id mod ih mod is equal to mod of a plus ib. So now you can write this as equal to root of a square plus b square into root of c square plus d square into root of e square plus f square into root of g square plus h square, which is equal to a square plus b square. So now squaring on both sides, we obtain a square plus b square into c square plus d square into e square plus f square into g square plus h square is equal to a square plus b square. Hence proved. This is what we had to prove by taking the mod. What we are getting, the value of that is this. So now next go. So here it's given that if 1 plus I by 1 minus I whole to the power of m is equal to 1, then find the least positive integral value of m. So in this, what do we have? The solution part of here, it is 1 plus I by 1 minus I whole to the power of m is equal to 1. So we have to find out what is the integral part of this. So which is equal to 1 plus I by 1 minus I into, we are rationalizing the denominator over here. So which is equal to 1 over here, which is equal to 1 plus I whole square whole to the power of m divided by 1 minus of I square whole to the power of m. This is equal to 1. Here you are getting it as 1 square plus I square plus 2i divided by 1 I square is equal to minus 1. So minus 1 into minus will give you plus. So 1 plus 1 is 2. Here whole to the power of m is equal to 1. So here this is equal to 1 minus 1 plus 2i divided by 2 whole to the power of m is equal to 1. So here you are getting this as equal to this is implied by 2i by 2 whole to the power of m is equal to 1. So here this is equal to I to the power of m, which is equal to 1. Know that since I to the power of 4 is equal to 1, which is nothing but I square into I square, which is equal to minus 1 into minus 1 is equal to 1. So therefore here, therefore the least positive integral value of m satisfying this equation is 4. Since I to the power of m, that is m is equal to a multiple of 4 we got, where k is some positive integer, where k is some positive integer. So therefore here we got m is equal to 4k. Here in this case we can take it as equal to 1. I'm sorry, 4. M is equal to 4 we are taking. So it is satisfying that, we can see very clearly.